So our video today is going to be on the introduction of volume. So that's not being at school, I decided to go to the Dollar Tree to see if I could find anything that had cubes in it. Because as you know, volume is measured in cubes, right? Because cubes have 3 dimensions. They have a length, a width, and a height. And a unit cube is what we use to measure volume. So it would have like this is almost, it's not quite, but like 1 centimeter times 1 centimeter times 1 centimeter, right? So I looked around the whole store. These were the only cubes that I could find until I got to the checkout register and I found these. See, y'all didn't think math was everywhere. Look at that, ice cubes. I was like, math really is everywhere. Look at those cubes. Well, they're not quite cubes. I don't think we could actually use them to measure anything because they're kind of lopsided. They're not all the same size. Like this one's like sideways and stuff. But anyway, I thought it was funny that they had gum that was made into cubes. So I thought y'all would enjoy that. See, math, it really is everywhere. Okay, so anyway, we use cubes to measure volume because cubes can fill things up. So here I have rectangular prism. It's just a paperclip holder, right? But I'm going to show you that you can use the cubes to fill this up. Now, we are going to pretend, we're going to pretend like these cubes fill the whole bottom of this. Now, they don't, but we'll just pretend that they do, okay? So, if I put these cubes in here, how many cubes fit in the bottom there? 4. So 4 cubes fit. And you should only really be able to see, even though we know they're cubes, you should really only be able to see the top part, which is a square. Okay? So when we're finding volume, your formula for volume that's on your formula chart for a prism, different shapes have different formulas, but for a prism, it has this capital B. And that capital B stands for the area of the base. Now, 6th grade would have been the first year that you learned about the area of the base. Okay, and you can see we have 1, 2, 3, 4 squares. And squares measure area. Now, the area of the base tells us how many cubes fit at the bottom of our shape. Okay, so if these filled up the whole shape, which they don't, it's just a little bit off, right? We would say that 4 squares would fit, or 4 cubes would fit at the bottom, because we know that the cubes have a depth of 1, right? So that's where we get the area of the base from. Let me show you another example of how we can look at that. Okay, so if this would be the first layer of our rectangular prism, we can see that if we wanted to know how many cubes this was, we would count 1, 2, 3, 4. This is 4 units long, and 1, 2, 3, 4 units wide, and then it's 1 unit tall, right? 1 unit tall. How many? Well, what would the area of that be? What would the area of the base of that be? The area is 16. You can see the 16 squares there. It's equivalent to the 16 cubes that fit. So that's why we use the area of the base, because it's going to tell us how many cubes fit in that bottom layer. Okay, then we're going to take the area of the base and we're going to multiply it times the height of our shape. Okay, so you see we have 2 congruent pieces. That's 1, 2, 3, 4, 1, 2, 3, 4. And I lay that on top. So I have 2. Come on now. So I have 2 layers of that. So that would be 16 times 2, which would be 32. So there would be 32 cubes there. So that area of our base was 16, right? And our height was 2, 1, 2. So that gave us a volume of 32 cubic units. If I put another layer, again, a congruent shape, another layer of 16, our height now goes to 3, right? So that 16 is repeating 3 times, or however many times our height is, okay? We put 2 more on there. Our height is now, there we go. Our height is now 1, 2, 3, 4, 5. So we would say, okay, that 16, the area of that base, the 16 cubes that fit at the bottom, right, is going to repeat 1, 2, 3, 4, 5 times. So our volume would have to be 16 times 5, whatever that is, 16 times 5 is, right? The cool thing about it is this formula works for any prism. Any prism. If you know the area of the base, then you multiply by the height of the prism, and it's going to give you the volume. Let me show you another example. Okay? So, I don't know. Have y'all ever had these? This is cheese. It's so good. Okay? This cheese is in the shape of a triangular prism. Okay? So here's our triangle, and I had to smush this a little bit because it actually comes in a circle, but it's okay. So there's the shape of our triangle, right? We have a triangle there, and it has height. So, and a prism has 2 congruent bases. So this is a triangular prism that has a triangle and a triangle. So it's a triangular prism. It's still a triangular prism even if I lay it on its side, by the way. Okay? The 2 congruent shapes are going to be the base. So we have 2 congruent triangles. So that's our base. So that's why it's a triangular prism, right? So this is a little bit less than an inch, but if we could figure out how many cubic inches are in here, then that would represent the area of the base. We would have to say 1/2 the length of that base times the length of this height, and we would divide it by 2 because it's a triangle, right? And we would find the area of that, and that area would represent how many cubes would fit, right? And then if I stack, let's just say 3, we would have to take that, whoops, and multiply it by 3. The number of cubes that fit in here would be the same number of cubes that fit here and the same number of cubes that fit here. So we would take the area of the base, which represents how many cubes fit in here, and multiply it times 3. Okay? Math is so cool. Let me show you with this. All right, so there's our triangular prism, right? We've got 4 here, 4 here. So if I find the area of that, remember our formula is area is 1/2 base times height. That's a triangle, right? So 1/2 of 4 times 4. Half of 4 is 2, and 2 times 4 is 8. So our area of that is 8 square units. So that means 8 cubes will fit in there, okay? If I repeat it, same size shape, right? If I repeat that 3 times, that would be 8 in this one, 8 in this one, and 8 in this one. So that would be 8 times 3, our height of 3, and that would give us 24 cubes that would fit in that triangular prism. Okay, so it holds true for any prism. Okay, it doesn't matter what kind of prism it is. It could be a trapezoidal prism, it could be a hexagonal prism, it could even be a prism. Well, it's not really a prism, but it could be a cylinder. We just learned about circles, and so cylinders work the same way. So if we pretended that the Oreo was a cylinder, right? However many, we could find the area of our circle and multiply by our height to find the volume of those Oreos. So this formula right here, that's where this formula comes from. Volume equals the area of the base times the height. So once you find the area of the base, remember that represents how many cubes fit at the bottom of that shape. And then the height of the prism represents how many times that repeats. And that holds true for any prism. Now we're going to learn about pyramids later, but for now we're just going to practice with prisms.